Hi everyone, welcome to the 10th video of module 9. And here we're going to study about some different types of pooling operations, starting from what is the need of having this kind of pooling layers in our CNN. And then what are some different types of pooling operations available. There are max pooling, sum pooling, average pooling, and the mean pooling. So let's get started. Now, unlike the convolution layer, pooling layer is going to come up with some multiple varieties. That is sum pooling, average pooling, max pooling, and there is one more type of pooling called as minimum pooling or the MIN, min pooling. The whole purpose of having the pooling layer in your architecture is to reduce the spatial dimensions by keeping only the important feature. Now, what do you mean by the important feature over here? If the feature is denoted by the maximum pixel values, you use max pooling. If you think that it is denoted by the minimum pixel values, you go with the minimum pooling. If you're really confused about this, you can go with the average pooling. And then you're also having something called as sum pooling. Let me explain all of this in a step-by-step fashion. If you are trying to implement the max pooling with this particular default settings that we have in TensorFlow and Keras, while implementing a pooling layer, that is the filter size or the pool size is 2 cross 2 and the stride value is set to 2. In this kind of settings, guys, no matter whatever kind of pooling you are going to use, it's going to reduce the overall output to the half of the input size. That is, if your input is 4 cross 4, it's going to reduce that input to 2 cross 2 in the output. That's something you need to know. For example, if you're having a 12 cross 12 image as an input, the output of this pooling operation with the same kind of default settings will be a 6 cross 6. So I hope that part is clear. And that's why we also call that pooling operation is also called as a downsampling or subsampling operation, because it's reducing the whole spatial dimensions by keeping the important features. So what are these important features is what I'm going to explain right now. If you're talking about the max pooling, every time we are going to focus only on the maximum pixels in each and every filter or the window. Because if we don't really call it as a filter, we can call it as a pool size or a pooling window, because over here there is nothing for filters to learn. Over here we are simply passing this whole filter and just extracting the maximum value. That's it. So if I'm putting a 2 cross 2 filter on top of this part, it's going to get you 9. And then because the strides are 2, you can skip 2 columns and go to 3, 4, 11, 1. What is the maximum value? Put it over here. Just like that, go 2 rows down. You will be having 21, 17, 31, 6. Maximum value is 31. Put it over here. Similarly over here, the output will be 19. So what are we doing? We are reducing this 4 cross 4 part to a single, we are reducing this 2 cross 2 part to one single pixel everywhere. And also the stride is 2. And therefore we are going to skip 2 columns, 2 rows every time. And therefore the output is reduced to the exact half of the input size. And like that, if you're talking about the sum pooling is simply going to sum up all the values in that particular window. So over here 9 plus 2 is 11, 11 plus 7 is 18. That's why 18 is written. Just like this, sum up these numbers, 19 will be there, so on and so forth. The average pooling will be the summation of everything divided by 4, because we're having 4 pixels over here. So 0 plus 2 plus 9 plus 7, we know it's 18. Divide that by 4, 4.5 will be the output. Over here, sum these numbers, 19 will be the output. Divide that by 4, take that average, you are getting 4.75, so on and so forth over here also. So that's how this kind of pooling works. If I'm giving you the example of what will be the output of the minimum pooling, it's only going to focus on the pixels with the least value in each of the pool. That is, over here, if I'm talking about over here, it's going to be 0. Over here, it's going to become 1. Over here, it's going to be 6. Over here, it's going to be 8. So 0, 1, 6, and 8 will be the output of the minimum pooling. And now here is a quick question for you. Will any of these pooling layers have any trainable parameters, that is weights and biases? Clear answer is no, because we don't have anything to learn over here. We have weights and biases only if they were to update and get to its optimal value to get something out. But over here, let's say for example, if we're talking about max pooling, it already knows that if you're defining what kind of pool size or the window size of that filter is, and if you tell that just pick out the maximum value, it's going to give you the max value. If you tell it to do the average, it's going to do the average and give you the average value. So there is nothing that this particular layer needs to learn, and therefore we don't require any model parameters. That is, we don't need weights or we don't need any kind of biases. Now, can you tell me which type of pooling is this? You can see that every time it's pulling out the maximum values. So what type of pooling do you think it is? Yes, it is max pooling. So that's it about this video over here. And unlike the convolution operation, there is only one video because there is not a lot of things you'll be learning about the pooling operation. Because the pooling operation over here is not learning anything at all. It's just to pull some kind of values outside of it, depending on what kind of function you are implementing. So yeah, that was about the pooling operation. In the next video, I'll be talking about the fully connected layers, which are the dense layers, and finally the output layer. So stay tuned for that.